Hello students, we are solving the IB Math EA past paper questions, and from today we start to solve the IB Math EA May 2023 paper 3 times on 1 past paper. Today we will be solving the question number 1, that is the first question of this paper, and in our next session we will be solving the question number 2 of the same paper. You will be getting the links to all the previously solved questions of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So without any further delay, let us start to solve the question number 1. The maximum mark is 25. In this question, you will be investigating the family of functions of the form f of x equal to x to the power of n times e to the power of negative x. Consider the family of functions fn of x equal to x to the power of n times e to the power of negative x, where x is greater than or equal to 0 and n belongs to the set of positive integers. When n equal to 1, the function f1 of x, this is fn of x. So when n equal to 1, it is f1 of x equal to x to the power of 1 or x times e to the power of negative x, where x is greater than or equal to 0. So part A's question is sketch the graph of y equals f1 of x, that is x times e to the power of negative x, stating the coordinates of the local maximum point. It is containing 4 marks, and since it is a paper 3 question, we can use the calculator to find the shape of this graph. Okay, the calculator, and we need the graph. Find it is x times e to the power of negative x. Okay, enter. And we need to get the portion which is having x greater than or equal to 0. Okay, so I'll be going to the Windows Zoom, the Windows settings, and I will be taking this, maybe I'm taking it as -1 just to see the y-axis, and x equal to 10 is fine, I feel, and I can take this as maybe -3 and this as +3. Okay. Okay, so this will be the shape of the graph, and we are seeing the x-axis is the asymptote, the horizontal asymptote. Okay, and we need to find the coordinates of the maximum point. So let us get that. Maximum. Okay, so this will be the coordinates of the maximum point 1, and is the x coordinate, and 0.367879. So up to 3 significant figures, it will be 0.368. Okay, now we have to sketch the graph. I'll obviously not be taking this part, the portion which is lying towards the left side of the y-axis. I'll be starting to draw the graph from x equal to 0, the origin. Okay, when x equal to 0, y is also equal to 0. So the graph will be starting from the origin. Okay, so this is the curve that I have drawn. Of course, seeing the graph from the calculator, in case you see, I have plotted the maximum point. The coordinates will be 1, 0.368 up to 3 significant figures. The graph is passing through the origin 0, 0. It will be starting from the origin, in fact, because x is greater than or equal to 0. But there is one more thing that you have to note, that is the concavity. Okay, in case you are not being sure of the concavity from this graph settings, I can go to the graph settings once more, and I can just change the y min. I can make it 1, and I can make this also 1. Okay, sorry, y min is -1, sorry, and y max is +1. Now it should be working. Yes. Okay, so now you see it is roundabout over here that the concavity point is changing. You don't have to take the second derivative and see where is the second derivative value equal to 0. Don't have to do that. Roughly it is around this point the concavity is changing. Over here the concavity is downwards, and over here the concavity is upwards. So you have to just be careful about your drawing. for the first portion, the concavity will be downwards and then the concavity will be upwards. Okay, you have to keep this in mind as well. Okay, and for the right hand side, I have put the arrow, but for the left hand side, the graph is starting at the origin. There shouldn't be any arrow for the left hand side. Okay, so this is the answer for the subpart A, and coming to the subpart B, and we have got 4 marks. Subpart B, show that the area of the region bounded by the graph y equal to f1 of x, that means x e to the power of negative x, the x-axis and the line x equal to b, where b is greater than 0, is given by this expression. So this is the graph, the x-axis, the graph is starting from x equal to 0, and there should be one line x is equal to b where b is greater than 0. We do not know the value of b, but the expression should be equal to e to the power of b minus 1 over e to the power of b. This we have to show. Okay, so we can use the formula for the area. Area will be equal to 0 to b. Okay, x equal to 0 is the left limit and the x equal to b will be the right limit, and x times e to the power of negative x dx. Okay, and now of course we have to use the integration by parts rule to integrate this expression, and we will be using the isolate. And the priority increases from e to I. So x is the algebraic function. It is enjoying a higher priority than e to the power of negative x, which is an exponential function. Okay, so therefore we will be writing, and what I think you remember, but in any case I am writing the formula for the integration by parts. It is in the formula booklet. This is equal to uv minus u dash v dx. Okay, and which one should we be taking as u? That is determined by this isolate. The one which is enjoying the higher priority will be taken as u. In this case, u will be taken as x, because the algebraic function enjoys a higher priority than with respect to exponential functions. Okay, so therefore u should be equal to x, and u dash should be, because we need u dash over here, therefore u dash is equal to derivative of x is 1, and v dash, because it is the integrand is u v dash, so u is this and this is u and this is v dash. Okay, so v dash is equal to e to the power of negative x, therefore v should be equal to integral of e to the power of negative x dx with respect to x, of course. Okay, so what is the integral of e to the power of negative x? It is negative e to the power of negative x, and we will not be using the plus c part for this integral. Area will be equal to uv. U is x and v is negative e to the power of negative x, and the limits are 0 and b, and minus 0 to b, u dash is 1 and v is negative e to the power of negative x. So negative times negative will be positive. I am putting a positive sign over here. E to the power of negative x dx, because this is u dash v. Okay, so this is, I am substituting b. So in place of x, I will be substituting b. B, I am writing the minus sign, this minus sign first, and then b and e to the power of negative b. Okay, and then minus, it is 0. Now I'll be substituting 0 for x. So again I have written this minus sign over here, and for x it is 0 and e to the power of times by e to the power of negative 0. Okay. And this one is, we know the integral of e to the power of negative x is negative e to the power of negative x. So there is a plus sign outside. So it is this e to the power of negative x 0 to b. Okay. And this is equal to, this part will be equal to 0. So negative b e to the power of negative b, and this is minus e to the power of negative b and minus e to the power of negative 0. E to the power of negative 0 is equal to 1. Anything raised to the power of minus 0 and plus 0 don't have any two separate values. It is basically 0. E to the power of 0 is 1. Anything raised to the power of 0 is 1. Okay. So we will be having this as, this can be written as negative b e to the power of negative b minus e to the power of negative b, and minus of minus is plus 1. Okay. But now we are having e to the power of negative b in the expression given. It is e to the power of positive b. So this can be written as negative b over e to the power of b minus 1 over e to the power of b. And I have to get the common denominator as e to the power of b. So I am writing 1 as e to the power of b over e to the power of b. Okay. So this gives us the expression as, I'm writing e to the power of b first because this is written first, and then I'll be writing this one minus b, and finally this one minus 1 over e to the power of b. Okay. So this is shown. You may assume that the total area En of the region between the graph y equal to fn of x and the x-axis can be written as En equal to integral of fn of x with respect to x, and the limits will be 0 to infinity, and is given by limit b tends to infinity, and the limits are getting changed. The 0 is staying the same, and the infinity over here, it is the b, and the integrand is the same. Okay. Subpart C, it is having two further subparts. The first subpart I says use L'Hopital's rule to find limit b tends to infinity e to the power of b minus 1 over e to the power of b. You have to find the limit. You may assume that the condition for applying the L'Hopital's rule has been met. So we don't have to show that this is an indeterminate form. Okay. So they are saying, asking us to assume that the condition has been satisfied. So we will be, let me write the subpart C's answer over here. Limit b tends to infinity e to the power of b minus 1 over e to the power of b. So this is limit b tends to infinity, and with respect to what should we be differentiating? This is important. When we have x tends to infinity, we differentiate with respect to x. Over here, we are having b tends to infinity, so we'll be differentiating with respect to b. Okay. So it is e to the power of b minus 1 over derivative with respect to b of e to the power of b. So this is equal to limit b tends to infinity, and derivative of e to the power of b will be e to the power of b, and this is derivative of b with respect to b, of course, will be equal to minus 1, and this is the constant term minus 1, so its derivative is 0. So this is the numerator, and the denominator is e to the power of b. Again, you are having infinity over infinity case, so again we will be differentiating e to the power of b minus 1 over this. So this is limit b tends to infinity and e to the power of b over e to the power of b. E to the power of b over e to the power of b is of course equal to 1. Okay. So 1 is the answer. Hence write the value of a1. Okay. So this is c and I. Okay. So a1 is equal to 0 to infinity, or I can write limit b tends to infinity that way. Okay. So limit b tends to infinity, and the integral limits will be 0 to b, and it will be x to the power of 1 because it is x1. So, a1. So it is x to the power of 1, e to the power of negative x dx. And we had found the expression for 0 to b x e to the power of negative x in our previous subpart, in the subpart b, as this. Okay. And we have found the value of this as 1. So, using the results of B and C, A1 is equal to 1. Okay. It is containing just a single mark. Okay. You are given that A2 equal to 2 and A3 equal to 6. Subpart D's question is use your graphic display calculator and an appropriate value for the upper limit, because the upper limit is just infinity. We cannot input any infinity in our calculator. So we have to put a large number. Okay. So, and En is 0 to infinity fn of x dx, and if you don't remember, fn of x was equal to e to the power of, x to the power of n and e to the power of negative x. Okay. So this was the expression for fn of x. And now they are saying use the graphics display calculator and an appropriate value for the upper limit to determine the value of A4 and A5. Okay, so fine, I can write the D over here. So let us first of all check whether we are getting the values of A2 and A3 as 2 and 6 respectively. Okay, we know that An is x to the power of n. An will be the integral, fn is x to the power of n and e to the power of negative x. So I can write this as a2 will be equal to 0 to infinity x to the power of 2 and e to the power of negative x dx. Let us find out what is the value. They have given the value to be equal to 2. Let us just check. Okay. I can go to the calculator page, and this is menu and calculus and numerical integral. The limits will be from 0 to over here. I need to give a large number, so I can put 6 nines. 1, 2, 3, 4, 5, 6 nines I'm putting. And or you can give any other large positive value also. Okay. And it will be, the expression will be x square times e to the power of negative x and dx. Fine. See, the answer is 2. Okay. Let us check the A3 also. So let me just copy paste. Copy and over here paste, Control V. And now the limits, they are staying the same. I have to just change the power of x. My goodness. Okay. Let me just Yeah. Okay. It is not allowing me. So again, I'm taking the same thing. 0 and 1, 2, 3, 4, 5, 6, and x to the power of 3 times e to the power of negative x and dx. Enter. 6. See a3 equal to 6. This is equal to 6. Okay. So a4 equal to, again it should be 0 to infinity. This time it will be x to the power of 4 x, e to the power of negative x dx. Let us see what is it. Okay. And this time I'll not be doing the copy paste because it is not allowing me. So numerical integral and 0, and this will be 6 nines, 1, 2, 3, 4, 5, 6, and x to the power of 4 times e to the power of negative x. Okay, and this is dx. Enter. 24. Okay, so this value is 24. It is just containing, this is containing 2 marks and this is containing 1 mark. Fine. But I don't have any more working to be given. They are asking us to use the GDC, so I don't even have to write using GDC. So this is x to the power of 5 e to the power of negative x dx. This should be equal to, this is the answer for the subpart I of subpart D. 24, A4 is 24. And now let us find A5. Okay, so again calculus and numerical integral and 0 and 99999 and x to the power of 5 times e to the power of negative x dx. 120. Okay. Okay, so we have given the values of A4 and A5 coming to subpart E. Suggest an expression for En in terms of n, where n belongs to the set of positive integers. Okay, so we know that A1 is equal to 1 from here. A2 is equal to, A2 equal to 2. This one is the working for subpart E. A3 equal to 6. A4 is equal to 24. A5 is equal to 120. Okay. So there will be some rows. There may be some rows. There may not be some rows depending on the value of n. And we need to get the expression for En because we'll definitely not be getting a numerical value. We do not know the value of n. So we'll be getting an expression in terms of n. So this can be written as 1 times 1. This is containing just a single mark. In case you cannot find, don't waste your time. Okay. But actually this part is needed for solving the last subpart of this subpart F. Because if you need to know the expression of En in terms of n. Okay. So this is 2 times 1. And this will be, this is equal to 6. So it can be written as, see, when this is 1, I'm starting with 1. When this is 2, I'm starting with 2. When this is 3, I should be starting with 3. And 6 is 3 times 2. Okay. and I am always ending with 1, so it is times 1. Okay. When it is A4, I'll be starting with 4. Okay. 4 times 6 is 24. So as soon as you see 6, you have to relate that 6 to this expression, because 6 is this. Okay, in place of 6, you should be writing this. Okay, similarly, this one, I have to start with 5. And if you realize, you have to realize, in fact, 5 times 24 will be 140, 120. Okay, so, and 24 is having this expression. So, okay, so this can be written as 1 factorial. This is 2 factorial. This is 3 factorial. This one is 4 factorial. This is 5 factorial. So therefore, an should be equal to n factorial. Okay. So this is the answer. An is n factorial. But if use mathematical induction to prove your conjecture from part E. In part E, we have proved that an is equal to n factorial. And the expression for an was given to be the integration of x to the power of n times e to the power of negative x with respect to x, and the integration limits were 0 to infinity. Okay, and this should be equal to n factorial. This is the conjecture from part E. That is what I was saying. The part E contained just a single mark, but this is containing 8 marks. But if you don't know what is an equal to in terms of n, then even if you know how to prove using the mathematical induction process, you will not be able to prove, because you will not be knowing what to be proved. Okay, so that is why subpart E is very crucial, very important. Although it contains just a single mark, but it is the doorway, the path to getting these 8 marks of subpart F. Okay, and this is what we have to prove, that is an equal to 0 to infinity x to the power of n e to the power of negative x dx. This is equal to n factorial, where x is greater than or equal to 0 and n belongs to the set of positive integers. This is what we have to prove using the mathematical induction process. Okay, so we can write that for n equal to 1, a1 was equal to 1, or factorial 1, from CII. Okay, therefore a1 equal to 0 to infinity x to the power of 1, because n is equal to 1. X to the power of 1 is x, so x times e to the power of negative x dx is equal to 1 factorial. Okay, this implies the relation is true for n equal to 1. Okay, let the relation be true for n equal to k, where k belongs to the set of positive integers. Okay, so ak equal to 0 to infinity x to the power of k e to the power of negative x dx, this should be equal to k factorial, because now n is equal to k, so this should be equal to k factorial. We are assuming this to be equal to true, this to be true. Okay, so to prove when n equal to k plus 1, ak plus 1 equal to 0 to infinity x to the power of k plus 1 e to the power of negative x dx is equal to k plus 1 factorial. Okay? Of course, using the mathematical induction process. This is the mathematical induction process. And now we have to integrate this. Of course, we will be using the by parts rule. So, and you know the by parts rule. For the by parts rule, we have to select the u. The u is selected using this eyelet. And in case you have again forgotten the by parts rule, let me write it once more. uv dash dx is equal to uv minus u dash v dx. Okay. This is the by parts rule. You have this in your formula booklet. And for the eyelet, A stands for algebraic functions, E stands for exponential functions. So algebraic functions enjoys a higher priority in comparison to the exponential functions priority. So over here, x to the power of k plus 1, it is an algebraic function, and e to the power of negative x is the exponential function. Therefore, x to the power of k plus 1 is u, and v dash is e to the power of negative x. Okay. So u equal to x to the power of k plus 1. Therefore, u dash is equal to k plus 1 times x to the power of k plus 1 minus 1 is x to the power of k. Okay. And v dash is equal to e to the power of negative x. Therefore, v is equal to the integral of e to the power of negative x with respect to x, which is equal to negative e to the power of negative x. Okay. And of course, we will not be writing the plus c over here. So now we will be integrating. ak plus 1 is equal to uv. u is x to the power of k plus 1 times v is negative e to the power of negative x minus u dash is this one k plus 1, and of course this is the definite integral, so I have to write the limits. Okay, k plus 1 times x to the power of k times negative e to the power of negative x. So negative times negative will be positive, so therefore I am writing positive over here, and e to the power of negative x dx. Okay, so this is equal to, I'm taking out this minus sign, and it is x to the power of k plus 1 times e to the power of negative x 0 to infinity plus, I can take out k plus 1 because it is the coefficient, it is a number, and 0 to infinity x to the power of k times e to the power of negative x. Okay, dx. And what is x to the power of k times e to the power of negative x? You see x to the power of k times e to the power of negative x when integrated with respect to x. The limits of integration, they are 0 to infinity, the same over here. This is equal to k factorial, which we have assumed to be true. Okay, so we can write this as negative x to the power of k plus 1 e to the power of times e to the power of negative x 0 to infinity plus k plus 1 times k factorial. And k plus 1 times k factorial is k plus 1 factorial. Okay. And now for this, we we should be getting k plus 1 factorial. So this is the k plus 1 factorial. Now we have to prove this part to be equal to 0. Okay. So how do we do that? First of all, we will be taking the infinity. I'll not be substituting infinity in place of x. Rather, what I can do is I can write limit x tends to infinity, x to the power of k plus 1. K plus 1 is any number times e to the power of negative x and minus of this minus. Reverse this minus. First of all, I have substituted the upper limit using the limits, and then I'll be substituting the lower limit, therefore this minus sign, and there was existing one minus sign, so this is this minus sign, and 0 to the power of k plus 1 times e to the power of negative 0, okay, plus k plus 1 factorial. Now this one is equal to 0 because it is given. See, for any value m can be any number, x limit x tends to infinity, x to the power of m times e to the power of negative x is 0. Okay. So m can be k plus 1. Therefore, when m equal to k plus 1, any number ak plus 1 equal to 0 minus times minus 0 or plus 0 hardly matters, it is 0 plus k plus 1 factorial equal to k plus 1 factorial. Proved. I can write this because limit x tends to infinity, e to the x to the power of m times e to the power of negative x is equal to 0 given. Okay. So let me show you once more. Limit x tends to infinity, x to the power of m e to the power of negative x is equal to 0. Limit x tends to infinity, x to the power of m e to the power of negative x equal to 0 given. Okay. So we have proved this. Therefore, we find that the relation is true for n equal to k plus 1 whenever it is true for n equal to k belonging to the set of positive integers, and we have found the relation to be true for n equal to 1. Okay. Therefore, the relation is true for all n belonging to the set of positive integers. Okay. So this is the answer for the subpart F, and we have got 8 marks. Okay. So Thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. In case you are liking my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my video. In case you have not subscribed to my YouTube channel till now, please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. We meet again very soon in our next session. We'll be solving question number 2 of the same paper. Till then, bye.